As always, you can find the code for this lecture in the GitHub repo in the folder code/week 10. However, this time there are two slight modifications. Normally, you get the newest version with a simple git pull. However, this time I'm using a so-called git submodule because in order to set up the private testnet, I'm using another GitHub repository, and I include that as a git submodule. And in order to get that, you have to call git pull with the option recurse submodules. The second one is about how to enter the Nix shell. As I explained in lecture 1, the way to most easily build the code examples is to first check out the correct commit of the Plutus minus apps repo and then run Nix shell and then do the build of the code example in that Nix shell. I explained that in the first lecture. However, when I did that this week, it didn't work for me. So Nix shell produced an error. And I asked my colleagues, and it turns out that it's not really clear why that happens, but I was not the only one that encountered that. So it might very well happen to one of you as well. So the advice I got for the time being before this is sorted out is to edit the nix.shell file, sorry, the shell.nix file in the Plutus apps repo and delete line 105. So line 105 happens to be Cardano minus wallet, .cardano minus wallet. So I deleted that, and then when I run nix minus shell, then it works. And then I can change to the code folder for this course, week 10, and do a Cabal build, and everything works. So the repository I'm including into our course repository via git submodule is WUFPool's Cardano private testnet setup. And that's a very nice collection of scripts that make it extremely easy to quickly run your own private testnet. So there are lots of options and very nice explanations, but I just use the default setup, which I think runs 3 nodes and 1 stake pool and creates 1 user. In this week's code folder, there's a scripts subfolder with lots of scripts, and one of the scripts is called start private testnet shell. And what that does is first it creates a temp directory for all the artifacts we will create during our experiments. So it first checks whether that folder already exists. If it does, it deletes it. Then it freshly creates it. It's an empty folder. It changes directory into Cardano minus private minus testnet setup, that is WUFPool's repo, and then calls the automate script in that repository. So let's do that now. So from this week's code folder, I just call that script in script start private testnet. And then the testnet is created and the nodes are started and configured and the stake pool is set up and so on. So it takes a couple of seconds, but it's actually blazingly fast. And that's it. So now everything is running. And I will keep this running in a separate window, in a separate tab of my terminal, and then can easily interact with it. So in particular, we have a node socket here, and we can use that to interact with this testnet node, with one of the testnet nodes. As I said, I kept the default parameters of this private testnet, and in particular, there is one parameter, this KES period. If you recall, there are so-called KES keys, and they have to be renewed every now and again, a certain period for security reasons. And here it's configured for, I believe, 91 epochs. And because the private testnet is running so fast, after an hour or so, you actually reach that 91st epoch, and then things stop if you don't renew your KES key. So if you take too much time, then that couldn't happen. Of course, it would be possible to change the 91 to a larger number, or you could also actually renew your KES key, or you can just try to not take too long. And of course, you can always restart the testnet. In order to restart it, you can just interrupt it, and then you should kill all Cardano nodes that are still running. Sometimes they are still running, and then you can just restart the testnet. And now we can interact with it just as we would with the mainnet or the testnet. The only difference is that we must set the Cardano node socket path correctly, and we must use the correct testnet magic, which in this case is 42. So all the normal Cardano CLI commands work. Must just correctly set the node socket and the testnet magic. So this script here, for example, it's called query tip, also in the scripts folder, queries the tip of the blockchain. If we do that now, then we see that my machine right now, I'm already in epoch 23, in slot 11,957, and in block 1,145. As I mentioned before, a lot of things are already automatically created for us. So in particular, in this folder, Cardano private testnet setup, private testnet addresses, are various artifacts. In particular, we see a user one has been created with verification key, signing key, payment address, staking key pair, verification key, signing key, corresponding staking address. If you recall from last time we talked about the Cardano CLI, there's a very useful query command, query UTXO, to get the UTXO at an address. So using, again, the correct node socket path and the correct testnet magic, and taking the address that I just showed you, so user one's address, I have this script, and if I execute it, I see that conveniently this user already has lots of funds. So if we count zeros, so we have 450,000 ADA in this UTXO and almost 450,000 ADA in that UTXO, so almost 900,000 ADA. Another query command the Cardano CLI provides is query stake pools, which, as the name suggests, lists all stake pools. So if we execute that, we see we have one stake pool already, and this is its stake pool ID. There's another query command, stake address info, which takes a stake address and then gives us information about that stake address. So as we saw, user one stake address has been created for us. Executing that script gives us the following information, that this stake address delegates to a pool, which of course is the only pool there is. This is the stake address in question, and we see that we already have quite a lot of accumulated rewards. So if I count digits correctly, it's at the moment 2,189 ADA. So how can we withdraw those rewards? So I wrote a script for that, which will create a appropriate transaction. And that script takes one argument, UTXO as input. As we saw, there are two. We can pick any of the two. So this is the argument. Next, I look up the amount that we can withdraw. There's a peculiarity with withdrawals in Cardano, so you can only ever withdraw the whole accumulated rewards, so you can't do partial withdrawals. So we must know exactly how many rewards have been accumulated when we execute this command. So I use the script I showed you before, this query stake address info user one, and then I use the JQ tool, standard Linux tool, to analyze JSON values and extract this reward account balance field. So amount now holds the available rewards. Then raw and signed are just file names for the unsigned transaction and the signed transaction. I just log for for debugging purposes this takes in and the amount, set the node socket path, and now I build the transaction, sign the transaction, submit it. So to build a testnet magic, then I must provide a change address. I again use user one's address, so the same one where I also take the input from. I must specify the out file for the unsigned transaction. I must specify at least one UTXO's input. I use this argument I passed in. And finally, this is a field we haven't seen before in the previous transactions we built. I use this withdrawal option, and that takes an address and an amount. So as address, I use the stake address, so user one stake address, and amount the one I computed earlier, the available rewards. Then I sign as always, so that's the same that we saw before. Magic, the file name of the unsigned transaction, file name for the signed transaction. Then I need my payment signing key because I'm spending this UTXO here. And I can only do that by proving that it's mine. So I must sign with my payment signing key. However, I'm also withdrawing, so I touch rewards sitting at the stake address. So in order to prove that I have the right to do that, I need the signing key for that stake address. Therefore, I need two signatures, two signing key files. And finally, I submit. So just with magic and providing the file name of the file to submit. So in order to try that, I need UTXO as argument. So I can pick one of these two. Let's pick the first one. So transaction ID and the index. So this is the first one. If I had used #1 instead, it would be the second UTXO. I execute it, and it seems to have gone well. Here we see this debugging information. So while I was explaining, we got even more rewards. So now it's 2,608 ADA. It seems to have worked. So we can now check UTXOs again. And we see this has changed. So this one here is now that one, so that remained untouched. But this one was spent and the new one was created here. And we see that the original 450,000 ADA are now 452,608 ADA. So the rewards have indeed been added. If we check the stake info, then we see that because we withdrew the amounts, they are gone, but because I spent some time explaining, we already accumulated another 52 ADA in the rewards in the meantime. So we have seen how we can interact with the private testnet and in particular try out staking related things. And it's very nice and convenient because epochs pass so fast, so we don't have to wait long for rewards to accumulate. But of course, none of what I've explained so far has anything to do with Plutus. So next we want to look at how to combine Plutus with staking. So in particular, instead of using a stake address that's based on a public-private key pair, on a verification key and a signing key, we will create a stake address that's based on a Plutus script. So then instead of providing the signing key for the stake address, for example, for withdrawal, we will provide the script file, the Plutus script, and then we can put arbitrary logic, as always, into the Plutus script, which will then govern under which conditions we can, for example, do a withdrawal of rewards. So we will look at that next.